Hi guys, welcome back again. This is the second episode of Network Automation Heroes, and I'm really pleased I got Eric today with me. I told you about it in the first episode. Eric is really the brain behind developing frameworks, building tools from scripting in the early days to actually building a framework that enables engineers to build any automation use case themselves. So I think here is over 20 years, even more, 28 years, we're just talking about it.
Yeah,
Since 1990, Eric, right, you've been involved in actually building tools or helping customers automate their
yeah,
network.
yeah. My history with NMS actually began in Canada in 1919 when I started heading up a group of NMS developers, and that was actually in the days that networks were still serial.
That's a long time.
Yeah, so we had a PBCX, yeah, like a computer exchange, which could be controlled, and well, there was a lot of management involved. Especially those terminal networks could become quite big.
Right.
So I've been working with NMS in that respect for quite a while. Later we saw, of course, ISDN and SDA. And any of this new technology.
ATM, you've
Well,
seen.
I actually ever saw the first Ethernet cables. I put them down as well. There was those really thick 1-inch cables nearly. So
Right.
yeah, the DEC networks.
So I think, and within that space and the developments from a technology perspective, you've been always involved in building tools or NMS landscape.
Yeah, both
Yeah.
from a management perspective and also for provisioning. That always has been the case. The first provisioning tool I started to build was for a national provider, and that was all still in the ATM era. So where the nailed-up endpoints had to match up throughout the network. And at that stage, the provisioning changes that came in on a daily basis were all written down and written out in command by command. And for some of the changes, you ended up with a packet of about 50 or 60 pages of commands that had to be typed in by the operators.
Almighty.
Yeah, so it didn't take me long to realize that the tool would do that far better. So we started automating in that respect from early on.
Like if you then you've been overseeing like decades but did you really see a lot of development from a network management perspective?
At that stage, no, definitely not. Network management was synonym with monitoring the network, and perhaps even understanding where a problem would be caused. The root cause analysis was a big word in those days. Yeah, so everything, all the event management was always concentrated on trying to figure out where was the problem, and then signaling the right person or group to try and fix it. Trying to define the impact of the problem was usually what NMS was all about.
Right.
Yeah, the provisioning part, getting it done properly and within time frames and tested and such. There was no indication whatsoever that was important.
It was a manual playing field.
Yeah, it was the domain of the people with the skills, and nobody ever bothered about them.
Right.
Yeah, it didn't matter how many people were involved in doing it.
Right.
Yeah, monitoring was the important part. Delivering the service was not really. Once it was there, it was okay, and if it caused problems, which it always did, that was the normal flow of operations.
Right.
Yeah.
So, I mean, what would you say is the key thing you've learned, from over these years that you built into the framework that you developed?
Well, let me try and clarify that a bit. Building tools to provision automatically is quite straightforward. That's not difficult at all. Where it starts getting complicated is doing the right stuff on the right service. Yeah, and making sure that a change wasn't a thing that only affected a single node or a single device, if you like.
Right.
Yeah. So, for example, if you write a script to create a new VLAN on an access device, as simple as that. Yeah. It doesn't stop there. There's always one or more connected devices, usually core devices, where that same VLAN also needs to exist and also need to be transported. Yeah. Unless you know what you're trying to build, there's no sense in trying to automate it. What you do need is some overview. Okay, well, this is what I want to do. Yeah, this is how it connects up to. And as soon as I know that, I know which device I also need to reconfigure. I know where it comes on in on what port. I know what port I need to reconfigure and how to add it.
Right.
Yeah? So as soon as you have an overview of what you want to build, you realize that scripting itself is not the story. Gathering the right information, yeah, and managing that is far more important.
Right.
So adding that VLAN to that device on the correct ports, that's fine, but also provisioning the uplinks and making sure that that exists on the right place at the right time, yeah,
Right.
is equally important. So managing that data that tells me where to put it is far more important.
This is, I think, a really important lesson for everybody, guys. I mean, I know that over the last few years, there has been a lot of new training on Python or Ansible training, but in the end, I think what Eric is saying, that's just one piece of the puzzle. It's actually executing the generation and job execution piece to the network, but you need to prepare things first. You need to have a way to store this data and the relationships on preparing your change.
Yeah.
Is that what you're saying?
That's what I'm saying. So we have concentrated quite a bit on building a framework that would allow you to manipulate that data on an abstract basis. Yeah, it understands what a VLAN is, it understands what a topology is, yeah, and then it links those together using a relationship.
Right.
Yeah, so an access device and its core devices have a relationship. And the relationship is, for example, the topology they have, but there can be other relationships like BGP or whatever.
Yeah.
Yeah. As soon as you define that relationship, you know what you're affecting,
Right.
and you know what you need to change and when and where. Yeah, and it is not just provisioning into the system, but also removing it from it.
Absolutely. Yeah. It's not just making a change, it's even deleting and cleaning your network.
It is as important.
Right. So how do you store that data? What is the...
Oh, usually you can do anything you like, but the database is the most effective one.
Right, so it's a database, right? So it's
yeah. If you want to take a look at the data model in the database, it is just a model of objects that everybody is familiar with in the networking arena. So you have a model for ports, you have a model for topology, you have a model for all the components that make up a network.
Right. So I mean, I know everybody is whatever you read on the internet, people say every network is a snowflake, so there's no way to automate things straightforwardly. I think what you have learned, me and all the people in our team, is that, you know, the way you can organize this data in your database, you have found a way to make this flexible. So you haven't used generic objects, but the way they connect to each other and relate to the type of network that in this case the customer has, you can build, you can model. Is that what you're saying?
That's right. Yeah, you have to make sure that the architecture that the designers come up with has to be flexible enough that you can actually put it down into a model. So it is both a hierarchical model, yeah, because you have, of course, a device with ports which have a hierarchical relationship, but you can also add in components like a DSCP, which can be attached to, well, whatever place it needs to be attached. Yeah, usually a port, but it can also be on another layer or another device.
Right.
Yeah, and by linking those together, you can create your network model that is a close reflection of the actual the design you put together.
Can you maybe give just a few examples? Just let me say, I mean, I know that people are saying, well, I've been using a database, maybe they've built their own Python and using some kind of custom, but you have supported a lot of engineers over the years to provide them with this framework to say it can be a data center network, a firewall network, a carrier Ethernet network.
Yeah.
Can you give some?
Yeah, I can give you an idea of how to tackle that. You don't just need objects within your database that reflect the correct attributes for that object, but you also need something that when you instantiate a new one, that it can also be filled automatically with the correct parameters.
Okay.
Yeah, so if you create a new subnet, yeah, for example, it needs to be populated with all the variables that are associated with it. And if you can lift that information directly from an IP plan, or it can inherit information from another device of another object, yeah, you can scale that up really well.
Okay.
Yeah. So you end up building a model where you not just define the actual objects that exist in the network, but also you have some master objects or you can call them classes if you like object-oriented models. Yeah. So a class is just a thing that can inherit its information to its objects.
I think this is a great synonym for
Yeah.
people if they want to compare this with like the Python languages. You have
Well, or any object-oriented
classes,
class. Yeah.
exactly,
Classes and objects, or
and inheritance of classes.
yeah, but we take it a little further.
Yeah.
Yeah, because it is a network and not just a straight object. So
Right.
there's always additional things involved.
Right.
So when you inherit, you also inherit part of the network. You also inherit part of the idea that you have.
Yeah.
Yeah. And the same, of course, apply to the design. If you, for example, create a new node in a network, that node always has a role.
Right.
Yeah. Whether it's an access device or a core device or an aggregation or whatever you like it, yeah, you always have a role. That role defines what it needs to do.
Right.
So with that role comes associated a set of interfaces,
Right.
yeah, a blueprint of interfaces, but also a blueprint of some other characteristics of that device,
Right.
even if that same hardware device is being used in different roles. So as soon as you create a new device, yeah, you tell it what role it has to have, and then it inherits all that is associated with that role as well.
Perfect. I mean, I explained in the first video that there's these 5 steps that basically you have find a way to organize together, right? From retrieving configs, which is an old way of doing things, but
Mhm.
at least it gives you the opportunity to check what people do outside of your control.
Of course.
And then there is the automation of the push, which basically you've developed, I think, over 18 or nearly 20 vendor modules in the last few years. So with the engine and the tasker, everything that underneath the framework allows the push
Mhm.
automation to happen. And then there's, well, the thing that basically pulls the data and the templates, the logic and the data together to create the configurations. I mean, so can you how does that work? Can you explain this a little bit?
As soon as the data is in place, if your database actually is a reflection of what you want to build in the network, or the modification that you want to have in the network, you can use a combination of what we call a scenario and the templates. A template tells you what command lines to generate for a given situation.
Right.
Yeah. So that is again something that the engineer or the designer brings into it himself, because it is his own design.
Yeah.
It is their lines. We never bother about validating if that is a true Cisco command or an Avaya command or not. We don't care.
And this could also be an API language or
any language. We don't
Right.
care what we are programming
Right.
at that stage.
Right.
Yeah.
So anybody is flexible to put in even YAML files or XML or netcom files.
If you have a programmable refrigerator, we can program it for
Right.
sure.
Right.
Yeah.
So you create an object, you define the role,
Yeah.
you create a template with that syntax.
And that template allows you to create the command lines.
Right.
If you're doing a CLI interface, if it is an API interface, it is similar.
Right.
Yeah, but you still need to have access to the data that drives it. Yeah, even
Perfect.
within an API, you need to drive it with data.
Yeah.
That is, yeah, and the templates are just a way of translating that data into command lines. Otherwise, you do it directly in the API. No difference
Right.
there. The next thing that you need to do is orchestrate those changes among the devices or make validations while you're doing so.
Right.
And we do that using scenarios. So a scenario allows you to say, okay, on a very basic level, it is a script language, very, very basic. It just all you need to understand basically is what you want to do, what commands you want to generate, and how to issue them.
Yeah.
Yeah. And the most appropriate one, for example, is I create, say, 10 command lines, yeah, for one node, and then I issue those 10 commands on that node. And if anything fails, we roll back. Yeah. If it is okay, we continue on with another 5 lines we need to generate for the next device, and then you can continue on. If that would fail, you can roll back
So
the last device or even the first one.
So the scenario language that you use is sort of similar like an Ansible workbook. Is that sort of fair to say?
Yeah, but a little simpler.
Yeah.
Yeah.
So
it is really straightforward.
Right. So an engineer doesn't need to bother about writing the language. You have a help file and a wiki and everything.
Yeah,
so people
right.
can just learn from an engineering perspective how that scenario should happen. and then they can store the data in the database,
Yeah.
and the entire process now can be prepared and it can be automated.
Yeah, what we try to do with the scenario is take away as much as we can the programmability that you need to understand in detail. You can concentrate as an engineer just strictly on what you really want to do.
Right.
Yeah, is generate those configuration lines and ensuring that they exist on that device.
Right.
If you have, for example, you want to verify something before or after you make your change. Yeah, we also use templates, for example, to read back any CLI output.
Right.
Yeah, you don't need to write code to do that. You just say, okay, well, I refer to this template that evaluates whatever comes back giving this command.
I explained this as like before we push, so you generate sort of from the data, from the templates, even from a design related configurations or as intended, then you push them with a scenario and template that will at runtime check the state, so you're not actually breaking something while pushing it.
Yeah, and you can do it both with commands and of course with configurations as well.
Yeah.
Yeah. So if you want, for example, to modify a subnet that exists on an interface, and you don't know what subnet it is, but you know that you want to make some modification, yeah, you can still go out as a job, request, okay, what is the subnet that I'm using on this interface, manipulate it in such a way, then generate the commands and push them back into the node.
Perfect. So the manipulation is you look at what the actual state information is, and you check on conditional, you use conditionals or any kind of logic that this simplified language allows you to do.
Yes,
so an engineer can say whatever he would do manually, you put in a scenario and it will check, and depending on the conditions, it will go each step of the way.
Yeah, depending on how complex you need it to be. Yeah, most scenarios that we see that engineers use are anywhere between 5 and 20 lines.
Right.
That he needs to put together. Templates usually the same. Yeah, they can be 20 lines long, or they can do the full configuration in them, depending on how generic they have to be.
Right.
Yeah. Also, in the templates themselves, they are not just plain code. Yeah. The plain CLI data itself. No, there's variable substitution going on in there as well.
Yeah.
They have conditionals, they have remarks, they have the ability to call another subnets or another templates. Even conditionals. There's a lot of functions in there that allow you to create templates, short as they be, with lots of smarts in them, so you can reuse them over and over again.
And guys, we're gonna go in far depth. We have this training video, the training web class that you can just register on the site, but there we will actually show you how this all works, and there is a training with the download of the software, and people can play around with it themselves, right? I mean, you created a download version for developers.
A lot of examples are included in them. Right. You need a little time to figure out how it works, but other than that, there's lots to learn from it. Absolutely.
And it gives also a lot of freedom, right? For any kind of use case that I mean, I've seen so many different types of use cases.
Yes.
And it's the same one code software that you have built that is able to do, from a simple use case, from changing subnets to end-to-end provisioning with integration to OSS systems. Basically, it's the same code doing it all.
You can build any case you like.
Yeah.
The tools are that generic to use and that specific to use effectively.
Awesome.
As an example, for the way we handle special cases, the exceptions in the design, it's just a matter of signaling in the template and say, okay, well, if you meet in this node, then that particular node has an exception, so please use this configuration instead of the other one.
Right.
Yeah. So it's just a matter of a simple conditional where you can put all your special cases in them.
Right.
Yeah. And you can continue to use that until really the network can be fully controlled.
So I know you have built this download version of NetEyes for developers, and basically we've basically set it up in such a way that they don't need to start modeling this stuff at first, because that's maybe a bit of a learning curve. But I mean, what would be the process if somebody has okay, I just, let's not go straight away on the network topology and service awareness, but I want to automate jobs to device level basis.
Yeah.
How can they import an Excel, put it into the database, and start using all these tools?
Yeah, we have two kinds of nodes, if you like, in the system. One is based on this CDB information, so that's just plain information. Okay, what is the vendor? What's the name? What is the domain? To retrieve the credentials to log in, and then you can just issue a job with the CLIs as you want them. So that's really the lowest level of support that we can have. As soon as you step up to the device where it actually is created using a model,
the core database of NetEyes,
the core databases where you can actually have fully fledged templates with all the relationships, the data it can access, the
custom parameters,
whatever anything that's related to your design that you put in there. Then of course you are really on a high, and you can go anywhere.
Maybe I can explain it to the guys, because we created this first training class that allows people to use, if they have an Excel sheet and they have information, we provide it through an import CSV importer into the database that Eric was talking about. So it falls into place in the core database of NetEyes. So now we have the freedom to prepare changes into the database, to manipulate data, prepare the logic, create your templates, and then all the tools will work automatically from there to create, generate, push, validate all the scenarios and stuff like that.
That's right. Yeah.
Awesome.
That's a good start.
That's a good start. I know there's a lot of more information I think that we're going to talk about in also upcoming episodes, Eric, but I definitely want to thank you a lot. I think you've been, from all the engineers that I've seen around working with you and your tools and your team, it's been, the flexibility, the ease of use, the not requiring to learn coding yourself, giving the power back to the network engineer, because personally what I've seen, guys, is that IT guys have come along and they've been pushing for automation from a server on cloud and VMware perspective, but from a networking perspective, you need networking knowledge. You need skills, even if it's CCNP or CCNA, but even the guys from a CCIE level, if you tell them how to automate stuff, they're a bit lost, right? So they need to learn either a new language in Python or in Ansible. But I think you've given them a great alternative to say, okay, you have this knowledge, we provide you the ways to structure it and to actually automate your process from a network engineering perspective without needing to code it, everything. Is that correct to say?
That we set out to do that, yeah. We built a tool for the engineers, not for the programmers.
Yeah.
So it's all the tools that we actually put together are always created simply because there was a need for something to do.
Right.
Yeah.
And I know there are many tools in there, right? So retrieve configs, generate configs, even resolve IP addresses in a database for troubleshooting purposes. There's 15 years of development going into this framework, but it must be, how do you manage this all together? Is it one code base on? Give you a bit of an insight maybe on the back end or how this works together.
Mostly it relies heavily on what we call vendor modules.
Right.
Yeah, and a single vendor module is of course vendor based, but it also supports the entire family. So we have one vendor module for Cisco iOS, but we also have a vendor module for Cisco XR.
Right.
Yeah, and most vendors need only one or two. And that also applies, of course, to not networking devices, but also for firewalls.
Even virtual devices.
Yeah, virtual devices, same story.
Yeah, they all run the same OS.
Yeah. So currently we have 19 different vendor modules offering quite a bit, but we're still aiming to add a couple of others.
Right. Yeah. And what I really find surprising, it only takes maybe 1 or 2 weeks for you guys to develop a new vendor module. But
because it is fairly straightforward for us to do so. Because, the basic vendor module is just doing screen scraping on the CLI using SSH or Telnet.
Right.
Yeah. So all we need to do is being able to log in, learn about its error messages, and also how to manipulate the configurations.
Right.
Yeah. So add configuration, remove configuration, download it, do OS upgrades. Right. Yeah.
And my screen scraping has been sort of the way in the past. I think you've seen new developments on an API perspective.
Yes, of course.
This makes it far more programmable.
Programmability improves. Yeah. Depends on what you're using. If you're using, for example, netconf, which is in most cases just an envelope using XML and on normal CLIs. Yeah. So that is really straightforward. to push forward, taking newer, really API bases like REST bases and such. It becomes more problematic because there are far too many API calls for every different case that you want to do.
Right.
Yeah. So that is less effective, but we still use it, of course.
I think the message that I conveyed in the first video, Eric, was, there's so much focus on programmability of the network and the push and the validation of the state, which I think, in your opinion, that I learned from you is just, it's not that relevant. There will be ongoing new methods on doing things on a device level. It's far more important how you prepare and generate the data and how you want to orchestrate it. So your process, from a process point of view, so you have a standardized way to generate. And this will remain true, you believe?
Definitely, because the design is still the one thing that drives the whole thing.
Right.
So,
even
so whatever provision you need to do, you always start out, okay, what do I want to create? What do I need to modify? And where are the variables that drive it?
Right.
Yeah, and if those variables are not consistently available, yeah, and they are not timed in such a way that they are consistent within the network, yeah, it is just a nightmare waiting to happen.
So you see it more as a data orchestration that is more important than just the execution itself.
Yes, absolutely.
And it doesn't matter whether there's new devices with SD-WAN or SDN controllers.
No.
That doesn't impact.
It has been true from day one. So when we started building a database for that information, it was always from the ground up intended to be an abstract network.
Right.
Yeah, it is not a virtual network. We can't simulate the network or its traffic, but it is an abstract network parameter-wise.
Yeah.
So whatever you do to that network, yeah, if you do your templates correctly, once you modify that database, yeah, that abstract network, the real network will just follow it automatically.
I know, because I've seen customers using it for thousands of nodes where they closed even down the CLI, and actually they trust the database to be the truth and to be, it's a design-driven enforcement in this case.
Yeah, that's more or less the holy grail.
That's the holy grail. And I see other customers say, we have an existing network, it's a brownfield network, we don't know specifically how it's configured, and there you have found a way to still generate the intended new config and then validate it at runtime, right? So that gives an opportunity for any existing network to be automated as well.
Especially in a large network with big PEs and such, where you need to make sure that the variables that you were handed over are actually still valid.
Yeah, or even shared devices.
Yes, and most of the devices are currently shared.
Yeah.
That's more and more the case.
Guys, I want to leave it for now. I hope you found it really interesting. Thanks a lot, Eric. We're going to do more in-depth sessions. I'm sure we're going to do lots of episodes over the next coming month. But
okay, looking forward to it.
Yeah,
thank you very much.
Thank you. I hope it was useful, guys, and see you in the next episode.